Hey, what's going on? The pictures were a little bit mixed up, so I don't know what order these are supposed to go in, but let's give it a try. Okay. The first and kind of biggest problem you have here, it gives you the same situation. Jose and Maria, it's Joseph and Mary. You're having Bible class. They both got $500. Jose allegedly is getting 10% compounded quarterly for 5 years. Maria is getting $500, 10% compounded continuously for 5 years. Okay, so you got two different equations here. Jose is going to use your general compounding formula, and Maria is going to use your continuous compounding formula. So again, P is just your principal. So Jose's got $500. 1 plus, well, your rate was 10%, so that's 0.1. N is the number of times it's compounded, so quarterly means 4 times a year it's getting compounded. And again, up here, this is 4 times a year for 5 years. So that's going to be 20 times. It's just the number of times it's compounded. So A is equal 500. 0.1 divided by 4 is going to be 0.025 to the 20th. Okay. And again, this is 1 plus 0.025. You could probably just write 1.025 in there. Save yourself the whole time. Okay. And then really you're just going to put that inside your calculator. So that's going to be what? That's 500 times parentheses. Oh, I didn't really need my spoke. 1.025 raised to the 20th power. And you're going to see Jose has got $819. And how many cents? And 31 cents. Okay. Maria's over here again. 500 times E, which is Euler's number, times your rate, which is 0.1, times the number of times, which is going to be for 5 years. Okay. So if you want, again, if you're feeling so inclined, you can go ahead and put that all in as one thing. You could say that that is 500 times E to the, so if you notice here, it is right above your natural log button, which we'll get to in a second, and that's going to be 0.1. You can actually put it all in just like this, times 5. Okay, and it should give you $824. So Maria will have $824 and some change, and 36 cents. Okay, so Maria's making a few more dollars, about $5 more. Again, they want to know exactly how much, so let's just go at 824.36 minus 819.31, and she made a whopping $5.05 more. If you can find either one of these interest rates for your money, go ahead and take them. If you can get 10% on any amount of investment after 5 years, good for you. Good, so that's the first one. Again, if you need an explanation of where these equations come from, you can get them, but for right now, I just want to focus on just plugging and getting the answers. All right. So question number 2, which just said consider this. So it said you're investing $15 at 11.5% interest, continuously compounded for 100 years. So I'm pretty sure this problem is supposed to like wow you into like, oh my God, if I invested $15, I'd have some crazy amount of money. Yeah, well, you find somewhere that's going to invest $15 and give you 11.5% interest, and I'd be very, very impressed. Okay, so again, what is it? It's continuous compounded T to ERT. So again, how much would you have? Well, how much am I investing? I'm investing $15 times E to the 0.115. Remember to convert that to a decimal, times 100. Okay. So it's 15 times E to the 0.115 times 100. So again, that'll just be 11.5 again. And you're going to get, oh my God, some crazy amount of money that after 100 years, maybe your grandkids would get, but even that, I wouldn't hold your breath. So it's 1,480. I'm sorry, 1,480,000. $736.57. 737.56. Okay. Forget that 56 cents. Okay. So again, that's a really, I think it's supposed to, wow, you're like, oh my God, like after this much time, I'd have this much money. Number one, you're dead. But also to get this interest rate on anything would be incredible, especially not something like $15. Okay. But again, if you got a bank account that's willing to give you that kind of interest for $15, hey, put $15 in there and give it to your grandkids. Okay. All right. So the next one is Carlos. Carlos inherited $10,000. Good for you, Carlos. It's 6% interest compounded continuously. So again, same equation. A is equal to P to the E RT. So again, P is going to be the $10,000 that Carlos inherited. And they want to know first for 10 years. So E to the 0.06 times 10. So again, if you wanted to simplify this before, you could say that's 10,000 times E to the 0.6 power. So again, what do we got? We got $10,000 times E to the 0.6, and Carlos has $18,221.19. $18,221.19. Okay. So that's good. Good for you, Carlos. Again, even at this point, 6% interest would be incredible. And the next question is probably the one that's a little more concerning: is that when will it triple? So I'm going to erase a bunch of this. I'm just going to leave kind of what we need. So they want to know when will it triple. So they want to know T, after how many years will it triple? Okay, so we'll leave that as T up there. And again, sometimes that word triple throws people off. Like, how am I supposed to do that? Well, triple $10,000 is $30,000, guys. Okay, it's nothing too crazy there. 60, okay. So again, 6% interest times how many years? Okay. The first thing you want to do, because we're trying to isolate T, get rid of the $10,000. Okay. So again, you're going to divide both sides by 10,000. Remember, this is a number, so you can. This is like saying, 30,000 is equal to 10,000 x, right? So we can divide both sides by 10,000. This is one definite number, e to the 0.06t. So what are we going to get? 3 is equal to e times 0.06 to the t power. Okay. Now to solve for a variable in the exponent, we use logarithms. You should know that. And if we want a log base e, we're going to use what's called the natural logarithm. So we're going to say ln, the natural log of 3, is equal to 0.06 t. Okay. So really, what is this really saying? Again, if you're not familiar, this is log base e of 3. Okay, is equal to 0.06 t. Okay, when we have log base e, we have a special name for that. We call that the natural log. So if you didn't know that, that might be something that's throwing you off. If you're still not sure about logarithms, you let me know, and I will gladly walk you through those again if you need it. So again, what are we going to say? We're going to say the natural log, which is right here, natural log of 3 is equal to that. So on abbreviated on here, that's 1.0986. What are we going to say? 1.0986 is equal to 0.06t. And the last thing we need to do is that we need to divide that by 0.06. So how many times does 0.06 go into that? We're going to divide it by 0.06. And we're going to find that it's going to take Carlos about 18.3 years. I forgot what it said to round to, so 18 years, and 0.3 is what, a third of a year, 4 months, so Okay, again, just watch. I forgot what it said to round it to, but about 18 years. Okay. Good. So again, if you have any more questions about the natural log, we'll go over that for you. Last one. Aiden's got $8,000. It's continually compounded. They want to know what kind of rate will he need to make it $12,000 in 20 years. I don't believe, does it say make $20,000 or Carlos, Jose, Aiden. For the account to grow to $12,000. Okay, so you just need $12,000 to grow $12,000. Okay, so again, what are we going to say? It's A, the amount is equal to P for the ERT. You should be familiar with that by now. What do you want? You want $12,000. How much you starting off with? $8,000. And what do you want to know? You want to know what rate do you need to make that in 20 years. Okay, so let's start by saying 12,000 divided by 8,000, it's going to be 1/2, I think. 12 divided by 8, okay, it's going to be, yeah, 1/2, okay. So again, how many times is 12.8? So it's going to be 1.5 is equal to e to the 20r power. Okay, so again, look, what are we going to do? We're going to say the natural log of 1.5, again, log base e of 1.5 is equal to 20r, right? So again, log base e, the natural log, is going to equal 20r, okay? And again, if you wanted to, you could just divide by 20 right off the bat. We'll divide both sides by 20. I'll say r is equal to the natural log of 1.5 divided by 20. Natural log of 1.5, which is that. And what are we going to do with that? We're going to divide it by 20. So again, what kind of interest rate does he need? He needs about a modest 2 point, I don't know, what was it? 0.27. 0.27. And if you think these decimal points don't make a difference, I promise you, ask the people at the banks, they do. Okay. So again, I hope this answers a bunch of your questions. If you have more, you just let me know, and I will gladly answer them for you.